just going to talk about radians. Now, what are radians? Well, radians are just another unit that measures turning about a point. And it does this by measuring the length in terms of pi of the circumference of a circle. So for example, if you have like a unit circle, so a unit circle just means a circle of radius 1, and you turn around like this, usually we measure the amount of turning in degrees. So what we do is we're going to look at finding a relationship with the turning in degrees and the turning at the circumference of a circle. So basically, if you turn 360 degrees, then the circumference around the outside of the circle, this is a unit circle, so radius 1, will be 2 times pi times the radius, which is 1, which is 2 pi. So when something is in terms of pi, when it's in terms of pi, we say that it is in radians. So if 360 degrees equals 2 pi, then if you divide both sides by 2, the conversion between degrees and radians is 180 degrees equals pi radians. Now the symbol for degrees is like that, just a circle. The symbol for radians is actually like that. You rarely see it. It's like a little C. So, that would be 5 radians like that. You rarely see it used, and normally we write pi radian. We write it in everything in terms of pi. So, for example, 180 degrees is pi. That would mean if I double it, 360 degrees is equal to 2 pi. If we get 180 and we divide it by 2, we get 90 equals pi over 2. If we get 180 and I divide it by 4, then I get pi over 4, because this is all based around this one here. So that means that's 45 will equal pi on 4. Get the 180 and divide it by 3. Okay, that means pi on 3 will equal, now 180 on 3 is 60 degrees. And then if we get 180 and we divide by 6, we get pi on 6. 185 by 6 is 30 degrees. So really, 45 degrees is pi on 4. 90 degrees is equal to pi on 2. And I better do 60 degrees is pi on 3. Because remember, pi 8 radians is 180, and 3 sixes are 180. So 3 into 180 is 60. 30 degrees is the opposite, so it's pi on 6. And 45 degrees is pi on 4. Okay, 180 is quite useful, that's pi. That's what we base all our conversions off. And then 360 is equal to 2 lots of pi. And they're all your basic angles in terms of pi. Now, basically, if you want to put something in terms of pi or in terms of radians, put it into radians, say you have 40 degrees, then what would you do to that? Because it's not like an easy standard one like 45, 60, 90, 180. What would you do to that to get it in terms of radians? Okay, so step 1, pi radians equals 180 degrees. So So that's 180 degrees equals pi radians. So now if I divide by 180 on both sides, then 180 divided by 180 is 1 degree, and that's pi on 180. So what I basically have here, I have 1 degree in terms of pi on 180. So if I have what 1 degree is, and I will now want to know what 40 degrees is, that would be 40 lots of pi on 180. So you basically make it 40 pi on 180, and then you can simplify it, which would be 2 pi on 9. So what actually happened here, when you think about it, to change 40 to radians, all we did was times by pi on 180. Okay, so if you're going from degrees and you want to go to radians, then you times pi on 180. Okay, so do you notice a couple of things? One way to remember that, do you notice the pi is on top when you want to go to radians? So let's just look at a couple more, and then we'll go back the other way and I'll explain radians back to degrees. So let's just say a third example. We have 120 degrees, and I want to change it to radians, so I times by pi on 180. So I put the radians on top. 120 on 180 pi, that would be 2 on 3 pi, and that's what it is in radians. So if you were going back the other way, it's pretty obvious that it would be the reverse. So I just want you to think about this. So on. So I want you to just think about if you're going backwards from radians. So if I had 2 pi radians on 5, or 2 pi on 5, all you have to do is replace the pi with 180, and you put it over 5. So it would be the same as going 2 times 180 equals, divided by 5 equals 72 degrees. And that's how you would change that one to degrees. Okay. But what if I had 7 pi on 3? So pi is 180. So you just got to go 7 times 180 on 3. 3 into 180 is actually 60. 7 twos are 42. So it's 420. Okay. Now you could also get this stuff, like get it to a decimal place. Or if I've already got it in degrees a minute, say I have 1.2 radians, so it's already as a decimal place, and you want to change it to degrees. Then if you want to change that to degrees, then what you multiply by is you multiply by, now I just want you to give you a little rule here for doing this, and you can use it for any of them. If you're given the pi, you just replace it with a pi, and you just put the 180 where the pi is. That's what's happened in all of these, 180 where the pi is. But this one is as a decimal place, so it's not actually in terms of pi. Now, pi radians equals 180 degrees. So if you did 1 radians, it's 180 over pi, because you've got to do the opposite. So if you times by 180 over pi, then you get 1.2 times 180 over shift pi equals 60. So it's going to be 68.75. That's degrees. If you change it to degrees of minutes, it would be 68 degrees 45 minutes. Okay, and that would be in degrees and minutes. So anything you have, like if you want to change it to radians, you times by pi on 180. And if you want to change it to degrees, you times by 180 on pi. So let's just look at a couple of things. So 2 radians you times, and you put the radians on top by 180, pi on 180. And if you want to go back to degrees, then you times by 180 on pi. And you notice that the 180 is on the top. So same way that I did this one here. See the times 180 on pi. So I just want you just to think about this here. Right, so 2 radians is that one. So let's just change 48 degrees 16 minutes to radians. Okay, so you just get your 48 degrees 16 minutes. I want to change it to radians, so I put the radians on top. So 48 degrees 16 minutes times shift pi divided by 180 equals 0.84. That will be to 2 decimal places. Okay, so let's just say we had 1.48 radians, so we want to change it to degrees. So the difference is, if you want to change it to degrees, you go 1.48, you put the degrees on top, which is the 180, and then you put the pi on the bottom. You get 1.48 times 180 divided by pi, and you end up with, if you press your degree meter button, 84 degrees and 48 minutes. Okay, so just a couple of things. Where is the radians actually used? Like, why are we doing things in radians? And it's because we're measuring the length of the arc outside, so outside on the circumference of the circle. So it's a way of measuring turning. Just like angles, it's a way of measuring turning as well. So if you had like this here, if this was 60 degrees and we were on a unit circle, then the arc length would be 60 on 360 times 2 pi times 1. So that's 1/6 times 2 pi times 2 pi. So when you simplify that, that would be 2 pi on 6, or it would be pi on 3. Okay, so if you look at the angle at the centre, which is 60, that makes sense that it's pi on 3, because if you got your pi and you changed it to 180, it would be 180 divided by 3, and that does give you 60, which is the angle that's there. So why do we put things in radians? We put things in radians because radians gives us a measure of length. So it gives us a unit that is going to match up with the real life lengths in practical examples. Time is another area where radians is used, because you can't measure time in degrees and minutes, but you can measure it within a decimal unit. And radians is a decimal unit because it measures the length on the outside of the circular arc.